Hey everyone, and welcome. Today, we are going to build a powerful, repeatable checklist that will let you tackle any new dataset you encounter using Pandas. Seriously, this is your new game plan for turning that initial data chaos into clear, trustworthy insights right from the very first step. You know the feeling, right? We've all been there. You run pd.readcsv and bam, you're staring down thousands, maybe millions of rows, dozens of columns, and you're just thinking, where on earth do I even start? It can feel like you've been dropped in a new city without a map.
And here's the thing. This is the part that really matters. Before you build a single model, before you plot a single chart, you have to face the #1 villain of every data project, dirty data. Things like missing values, duplicates, weird outliers, they can completely destroy the credibility of your work. So here's our battle plan. First, we'll walk through a simple 3-command checklist for that crucial first look. Then, we're going to put our data through what I like to call the gauntlet, a series of critical quality checks. By the end, you'll have a rock-solid, repeatable workflow you can use every single time. Let's get started. Okay, phase 1 is all about getting the lay of the land. Think of these next 3 commands as your superpower for that initial exploration. They're simple, they're fast, and man, are they revealing.
So here's our simple roadmap. First, we get the blueprint with info. Then we get the statistical story with describe. And finally, we count up the categories with value counts. Let's break down each one. We always start with df.info. This is like looking at the architectural blueprint for your data. In one shot, it tells you the number of rows, the columns, their data types, and most importantly, how many non-null values each column has. This is your first and fastest way to spot columns with missing data.
Now, here's a pro tip that a lot of people miss. See that little plus sign in the default output? That's Pandas telling you it hasn't fully calculated the memory used by text columns. But if you pass in memory usage equals deep, you force it to do a full calculation, giving you a much more accurate picture of how much memory your data frame is actually eating up.
All right, next up is df.describing. If info is the blueprint, describing tells the statistical story hiding in your numbers. With one command, you get your mean, your standard deviation, the minimum and maximum values, and those percentiles, they give you a fantastic feel for how your data is distributed.
But what if you have both numbers and text in your data? Well, by default, describe just ignores the text columns. But check this out. The secret is include all. This little parameter tells Pandas to give you a summary for every single column. For your text data, you get the count, number of unique values, the most common entry, and how often it appears. It's so useful.
And the third member of our trio is df.valueCounts. This is your absolute go-to for any categorical column. Think things like department names, salary levels, product categories. It instantly gives you a head count for each unique value, so you can see the distribution and spot any imbalances right away. And don't sleep on value counts, it's more powerful than it looks. If you set normalize equals true, you get the results as percentages, which is perfect for reports. And even cooler, you can use the bins parameter on a numeric column to chop up continuous data into groups. It's a great way to turn a number into a category on the fly. Okay, our initial recon is done. Now it's time to get serious. We're moving from a high-level glance to a really rigorous validation phase. It's time to put our data through the gauntlet and make sure it's solid enough to build our analysis on. First up in the gauntlet is the single most common data quality problem you will ever see: missing values. We got a hint from df.info, sure, but now we need to dig in and really understand what we're dealing with. Now, here's a crucial detail about how Pandas works. It uses a special value from NumPy, np.nan, which stands for not a number, to represent missing data. The tricky part is that np.nan is technically a float, so if you have a column of integers and even one value goes missing, Pandas will automatically convert that entire column to a float type. It's a subtle thing, but it's super important to be aware of. Next challenge: duplicate records. I like to call these the silent killers of good analysis. If you have the same row appearing multiple times, it can totally inflate your counts and skew your averages, leading you to some very, very wrong conclusions. The good news is, finding these issues is really straightforward. To get a simple count of missing values in every column, you just chain .isNull with .sum. And by the way, .isNa does the exact same thing. Then, to actually see all the duplicated rows, you just use this simple Boolean filter. Once you find them, you can decide what to do next, which is usually just getting rid of them. All right, now we go hunting for outliers. These are data points that are just so different from everything else that they look suspicious. Maybe they're data entry errors, or maybe they're real. But either way, we need a systematic way to find them. A really robust way to do this is with the interquartile range, or IQR method. It sounds complicated, but it's not. You just find the range between the 25th and 75th percentiles. That's your IQR. Then you set up fences. Anything that falls below 1.5 times that range from the bottom or above 1.5 times that range from the top gets flagged as a potential outlier. This next check is where you have to put on your detective hat. The data might be technically clean, no nulls, no duplicates, but does it actually make sense in the real world? It's time for a sanity check. And this is a brilliant example using the California housing dataset. It's just plain logic that a house can't have fewer total rooms than it has bedrooms, right? Well, we can write a single, simple line of code to find any rows in our data that violate that fundamental rule. And to round out our gauntlet, here are a few final rapid-fire checks. Always double-check your data types with df.dtypes. Make sure numbers fall in a valid range, like age can't be negative. And for things like dates or email addresses, you can use regular expressions to make sure the format is consistent everywhere. So, there you have it. We've made it through the gauntlet. By combining that initial quick exploration with these tough quality checks, you now have a repeatable workflow. This process is your new superpower. It's how you turn that initial data chaos into a foundation of solid trust. And here it is, all in one place, your reusable checklist. This is the one you'll want to screenshot. First, you explore. Use info, describe with include equals all and value counts. Then you validate. Check for missing data and duplicates, hunt for outliers, and verify the logic. This is your new standard operating procedure. Because at the end of the day, that's what this is all about. Every single dataset has a story to tell, but you can't hear that story clearly through all the noise of bad data. By following this checklist, you're making sure that you're ready to listen.